Hi, everyone. So I'm going to talk about a study that I've been working on with Nancy Segal at California State University, Fullerton. And when I say study, I feel like this has become more of a sort of an obsession over the last sort of year or so. So what I'm going to show today, amongst other things, I've read cover to cover more than 20 books and monographs and probably more than 100 papers as well for this. And there's still stuff. Every time I read something, there's something else that comes out the woodwork. As you can probably imagine with this, I'm looking at reared apart twins. They're quite rare. So when people do find them, they tend to just go write a whole book about them. So this is where I'm sort of having to sift through so much stuff. I didn't realize it's going to be quite a project like this when I started on it. So I'm not going to harp on about this too much. I figure everybody here knows a fair amount about handedness, but I'm going to go with a statistic about 90%, depending on your criteria, etc. So about 90% tend to favor the right hand. It's also been commented for more than 100 years about how twins sometimes are discordant for handedness. And this can be quite striking, particularly when we talk about monozygotic or identical twins. So if you think, for instance, Bob and Mike Bryan, if anybody's a tennis fan here, identical twins who played for the US for many years. Bob plays left-handed, Mike plays right-handed, but they're by anything else, when you see the two together, they're pretty much indistinguishable. So Danforth in 1919 said rather a surprising number of twin pairs seem to be composed of one right and one left-handed individual. Twin research also suggests around 25% heritability for direction of handedness. So I'm going to come back to this point a little bit later. So here we have just some examples of some twins. So on the left-hand side, you can see this is Joel and Benji Madden. If anybody likes sort of punk rock music, they're the lead singer and guitar player, respectively, from Good Charlotte. So you can see that the two of them have a strikingly similar resemblance. They're monozygotic twins. This results from the splitting of one fertilized zygote. So they have 100% shared genes identical by descent. On the right-hand side, we have Mary-Kate and Ashley Olsen, famous for, I'm not quite sure what, I think they're fashion designers these days or something like that, but they're fraternal or dizygotic twins. So you can see there's quite a similarity between the two, but they're clearly not identical if you look closely. So this is, so dizygotic twins resulting from sort of simultaneous fertilization of two separate ova by two separate sperm. So in their case, they will be no more alike, genetically speaking, than any other pair of full sibs. So in the classic twin design, we're comparing the similarity or the concordance rate between our MZ twins and our DZ twins, with the idea that if there's a higher correlation, a higher concordance in the MZ twins, then this suggests some genetic underpinning to the trait under study. I'm sure everybody knows this already, but I thought I would sort of recap. Now, one of the problems, of course, with looking at twins in this classic twin design, well, some people think this is a problem. A lot of work's been done on this and suggest probably isn't in most cases. But when we're looking at whether a greater similarity between MZ twins compared to DZ twins, some people will say, well, actually, the environment for MZ twins is more similar than it is for DZ twins, and therefore their greater similarity on whatever might be due to this. So a way to sort of get around this is to examine twins that actually were reared apart. And as I mentioned earlier, obviously twins like this, it's pretty rare. When you think about it, it's not a usual circumstance for people to grow up. But we've got here the first report in the scientific literature of twins reared apart. This is Bessie and Jessie. This was first reported 100 years ago. So Bessie and Jessie were, I think their mother became very ill around childbirth, and they were essentially separated at 2 weeks of age, and they didn't meet or correspond until they were 18 years of age. So obviously then it's quite interesting to see, well, are they similar? They've grown up in different environments. They've got the same sort of genetic architecture, so to speak. And in some regards, Bessie and Jessie were very similar, in other regards, quite different. Interestingly, they were actually, their handedness was reported in a paper by Muller in 1925. And it was commented, so probably quite a rare instance here, it was actually commented that both of these girls showed left-hand preference in childhood, but one of them was, and I quote, broken of it. So in cases like this, what I've tried to do when I talk about, when I've sort of pooled case reports together and things like this, if there's sort of evidence of prior sort of left-handedness, even if handedness has been switched during childhood or something like that, I've tended to try to code these cases as non-right-handed. Even if, for instance, in adulthood, they report being right-handed and they write right-handed, if they actually were sort of showed left-hand preferences in childhood, then they've gone in the non-right-handed category. So what we have here is basically a quick sort of summary of what I found. So this is, as I say, going through sort of 100 years of literature. There are a number of large studies that have been conducted, sort of empirical studies of twins reared apart that have been conducted in the UK, the US, Denmark and Sweden, a few smaller studies as well, and then lots of sort of case reports scattered around. But when I sort of put all of this together, the first thing that I think is quite striking is actually how many cases we have. So we've actually got, so all twins together, we've got 468 pairs of reared apart twins for whom I was able to identify handedness. In my supplementary materials for my paper, which was just rejected last night, by the way, but I will try again. It's too much work for me to give up on this one. But yeah, so basically with the 468 pairs here, this is only for those that we have handedness data. In my supplementary materials, I've actually put together all of the cases, even those where we don't have handedness, because as much as anything, I've trawled through so much literature. I'm hopeful that this might be useful for anybody else going forward who's interested in something other than handedness, that they can identify sort of all of these cases and sort of put this stuff together. Either way, a couple of things just to note here is, firstly, you'll notice that we've got considerably more female pairs than male pairs. Why this should be, I'm not entirely sure. A couple of the, well, one of the studies from Denmark by Yul Nielsen was actually sort of based on a population survey. So, you know, get sort of hopefully all of the reared apart, in this case, MZ twins. They didn't look at DZ twins. But otherwise, like a lot of times, obviously, it's going to be sort of selective reporting of a lot of these cases. So I don't know why we've got more females than males, but we do. The thing that's perhaps more concerning, though, is in terms of our MZ to DZ twins. So we've got more MZ twins that are reported than DZ twins, even though DZ twins outnumber MZ twins about 2 to 1. In this case, with our analysis, I'm comparing only same-sex DZ twins with MZ twins, but you would still expect there to be more DZ twins if there wasn't sort of selective reporting. This probably simply comes about because identical twins reared apart, you know, it's a very engaging topic. An individual pair like this is probably more likely to be reported. They're also more likely to find each other because there's often these twins find each other through cases of mistaken identification. And this tends not to happen for DZ twins. Though there was one case where sisters were actually reunited like this because people thought they looked like identical twins, and it turned out they were actually dizygotic twins, just very similar looking. Okay, so to sort of compile this, what we have in the last table, into something a little bit more sort of consumable, for want of a better word, what I've done is I've put here the data from my study, but also from a recent meta-analysis by Pfeiffer et al., where so Pfeiffer et al. Have sort of looked at the concordance rate of hand preference direction in MZ and DZ twins that were reared together. You can see they got a much more impressive sample size than me, but you know, this is to be expected because they're easier to sort of recruit. So this is the MZ pairs and DZ pairs. You can see they got a very slightly higher concordance rate in the MZ pairs and the DZ pairs, only sort of like about 1% difference in concordance, but this was actually statistically significant, which would be consistent with a sort of genetic effects here. But again, I will come back to this point with the classic twin design in terms of direction of hand preference in a moment. So for my study, though, you can see here, so we've got of our MZ twins and our DZ twins, that the concordance rate is a little bit lower for both of these. I've not compared any of these numbers statistically, by the way, and I'll explain in a moment why. But you can see, so we've got slightly lower concordance figures. The thing that's perhaps a little bit more surprising, though, is that the concordance for DZ twins is actually higher than it is for MZ twins, which is kind of difficult to explain why that should be. I wonder, though, if the slightly lower concordance could be something along the lines of, if twins grow up in different families, say you have two twins that show left-hand preference, say their handedness would be switched by their parents or attempted to be switched by their parents, bearing in mind that a lot of these studies from many, many years ago, if they grew up together, they would have that same influence. Whereas if they grow up in different families, it might be that switching happens for one of the twins and not for the other, or something like this. So I have tried to take this into account, as I say, as best I can, but it's not always easy. Now, I mentioned just now about an issue with sort of heritability estimates from the classic twin study, classic twin design when it comes to hand preference. And the reason for this is that we have the equal environments assumption. So the idea that the similarity of the environment that a pair of MZ twins grow up in is equivalent to the similarity that a pair of DZ twins would grow up in. And in its wide sense, you can think of this as being sort of in general, but you can think of this in a narrow sense in terms of it needs to be that if there is a greater similarity of environment in MZ twins, for instance, that this isn't related to the outcome of interest. But one of the problems, so there's been a lot of work, as I say, over the years looking at the equal environment assumption, and it seems to be that in most cases, at least, it tends to hold. But direction of hand preference is actually one of the few cases where this assumption may be violated. And the reason why is that the certain sort of early developmental processes involved with zygotic splitting, they occur for MZ twins, but they don't occur for DZ twins. And this actual process might then relate to handedness, because you can have this sort of, there's a lot of debate over this, but potentially sort of mirror imaging kind of effects that may happen with a zygote splitting at different stages, but you don't have these processes happening for DZ twins. So my co-author, Nancy Seagal, essentially says, because of this, that heritability estimates derived for direction of handedness from twin studies may be quite unreliable. You don't really quite know what they tell us. However, this may be the case for the direction of hand preference, but it's not an issue for the strength of hand preference. So if we have, for instance, a zygotic splitting event that, let's hypothetically say this results in one twin that's right hand preference and one that has left hand preference, we would assume that the strength of handedness probably isn't going to be affected by that event. However, we do also know there's the caveat, of course, the strength of hand preference may be weaker on average and perhaps more variable within left-handers and right-handers. However, another sort of way to combat this would be that we can restrict our analyses just to those twins where they're both right-handed or something like this, and see if we get the same results. So anyway, that was sort of the first part of my study, was this sort of overview of what do we actually know from the literature, which I've then just said, well, essentially, well, even if we do have a higher concordance for MZ twins, does this really tell us anything? So the other part of what I've done is I've used data from the Minnesota study of twins reared apart. So this is the MISTRA. This has run for about 20 years, where the researchers in Minnesota, they recruited not just MZ twins, but also DZ twins that were reared apart. Altogether, by the sort of close of play of this study, they recruited 137 twin pairs that were reared apart since early life, most of whom we have handedness data for. So what I did is I've looked at these twins for, well, I've done sort of four main things. First is we've looked at strength of hand preference. They had the Krovitz-Zehner handedness inventory as part of the sort of battery of tests they did. So I've looked at that, but I've looked at this in terms of I've calculated a laterality index, and then I've removed the sign. So we're looking purely at the strength of hand preference, regardless of the direction, which again sort of negates this issue with the potential violation of the equal environment assumption. The other thing is we have the Purdue pegboard task that a lot of the twins also did, a slightly smaller sample of them, but still most of them did this. And then I've done exactly the same here in terms of an absolute or unsigned laterality index. And I've looked at the right-hand speed and left-hand speed for this as well, just as much as anything, because I think it's quite interesting to see whether twins reared apart are resembling each other on this measure. So what we have on the screen here, there's quite a lot of numbers. Don't feel that you need to look at all of these. Also ignore this bit for now. I'm going to come back to the top bit. The first thing to note is that for each of these, I've basically done 3 different types of analysis. So I've done intra-class correlation coefficients, essentially to see, are the twins more similar than you would expect by chance? And then I've also done R to Z tests to see if the strength of the association is different. What I've done though is I've done the analysis for all participants. Then I've removed all participants who reported either that their handedness had been switched or at least that attempts had been made to switch their handedness, which is actually quite a surprising amount. If you look at how much the N's decrease, again, think the timing of when these twins would have grown up, handedness switching was much more sort of commonplace. I've then also restricted the analysis to just right-handers, or rather twins in which both report being right-handed. What we find then for relative hand skill strength, so this was for the Purdue pegboard task, we essentially find that the twins, be them MZ or DZ, don't resemble each other. There's no significant association there. This is sort of similar to, I think, a paper Chris McManus did using the Colorado adoption study, where there was sort of no association between strength of handedness of biological parents and the adopted away children. This might also be that it's reflects a fairly small effect and low statistical power. For right-hand speed and left-hand speed, however, what you can see, basically all the bits in bold here are that the twins, the MZ twins that were reared apart, are more similar than chance on their speed on this task. And this is the case whether or not we remove the twins that were reported handedness switching, or at least attempts at this. And it's the same if we retain only the right-handers that didn't report any attempts at handedness switching. So this is fairly strong evidence that there's a sort of moderate sized heritability for right and left hand speed, at least on the Purdue pegboard task. However, the bit that my job for you all today essentially is to try to figure out how I found this and what it means, is if we go to the top here, when we look at our hand preference strength, we find no correlation for our MZ twins, but we do find a significant similarity for our DZ twins. Bearing in mind, again, that these twins are reared apart. So we can't explain this in terms of a shared environmental effect, and we can't explain it in terms of non-shared environment. So basically, the only thing left is the genetics. However, we then haven't got an effect for our MZ twins, who we would expect to have a stronger concordance for this. This effect kind of goes away when we look at those that weren't that didn't report switching, but if you see the p-value is still close to significant, and then it re-emerges as being significant again when we stick to just right-handers that weren't switched. And in this last analysis, our R to Z test is also significant, i.e. a significantly stronger positive correlation in our DZ twins compared to our MZ twins. So as I say, this is rather difficult for me to explain. Here is just this shown graphically. So you can see this is our correlation here of our DZ twins for strength of hand preference, and then nothing going on for our MZ twins, nothing really going on for strength of relative hand skill. And then if you look at our sort of blue parts here, you can see you've got this neat sort of positive correlation for our similarity between MZ reared apart twins for speed on the Purdue pegboard task. So to sort of summarize and come to some sort of conclusion about what I found here, so I think the first thing is, for the first part of the study, we got 468 reared apart twin pairs. I think this is, I was surprised as much as anything that there was so much there. In some of these cases, their data from, say, there's a study in Sweden that's looked at this called the SATSA, and they have the data for all kinds of things for their reared apart twins available online. So I basically analyzed this in relation to handedness there. Also, Jarkko Caprio kindly shared with me data from a study in Finland, likewise, that they had handedness data for about 100 pairs, I think it was, of twins reared apart. So there's data that I've added in here that, well, otherwise wouldn't sort of see the light of day. But we've got a lot of case reports and stuff as well. But this is sort of all of it together. And we find this sort of strange, slightly higher concordance for DZ than MZ twins. My guess with this, probably as much as anything, is that it's going to be relating to power. Although it's, I think a good sample for reared apart twins, when you're looking for a small effect size, it's probably still not going to be adequate. The other thing is, I wonder whether, this is purely speculation, but I wonder if MZ twins that are discordant for handedness, this is maybe more likely to be commented on in papers because it's more striking. When you have MZ twins, be them reared together or reared apart, who are both right-handed, people probably don't really pay much attention to it. But if one of them's left-handed, then maybe this gets reported more. This is just an idea. It may or may not be, may or may not explain why we've got this effect. We didn't find any evidence for heritability for strength of relative hand skill. As I say, this was consistent with Chris's study of adoptees. And maybe this, again, it might, well, I guess there are a couple of possibilities. One is that strength of hand preference, strength of relative hand skill, sorry, doesn't have any genetic underpinnings, but equally it might well be that it's just that the effect size is too small and that the study is underpowered. Something that I was quite surprised is there's very little actually on this to be able to compare with in the literature, not just with reared apart twins or with twins at all, but in terms of any sort of genetic underpinnings. They tend to focus purely on the direction of handedness. So this is something, if any of you are interested in going forwards, get me an answer on this, it will be great. Is there some sort of genetic underpinning for strength of handedness as well? As I say, the effects from the MISTRA data were a little bit difficult to sort of come to some firm conclusion on what's going on, because we got this DZ correlation for twins reared apart for the strength of hand preference, but nothing for the MZ twins that were reared apart. Now, as I mentioned earlier, because the DZ twins reared apart don't share an environment, but they do still share genetics, it's really only sort of compatible with a genetic effect, which might suggest that we found that, and it's just an effect size that was maybe overinflated in our sample, and that we've made a type 1 error when it comes to the MZ twins. Another possibility, of course, would be the idea of sort of selective placement, that actually twins are placed in homes that are more similar than chance, and actually so they do kind of have a shared environment even if they grow up in different places. But the evidence for this from the sort of empirical studies of twins reared apart doesn't seem to be explaining very much about or much at all about outcomes of interest. So I think it's unlikely to be this, though obviously I'll listen if people have ideas on this. So yeah, this is pretty much my overall findings. They're a bit not quite sure what to make of them yet. I'd like to thank, obviously, my collaborator, Nancy Seagal, for letting me have access to the MISTRA data, and also for putting up with my many, many emails to her about this. And also thank you all for coming along and paying attention to me. So any questions?
Thank you very much.
Yeah, thank you very much. That's a very cool project, and I would not understand why anyone would reject that. Just when you introduced the whole paradigm, you said something that the major advantage of having those twins reared apart is that you actually could disentangle like environmental effects. And now you basically found that the concordance rates were pretty much the same as in our beta. So would this now imply that the environmental factors do not really play a role for handedness, or what would you say?
I would I would say to take this study in light of everything else within the literature as well. I wouldn't want to make some sweeping conclusion like, oh, there's no genetic underpinning to handedness, because clearly the rest of the evidence suggests that there is. We have this evidence from, molecular genetic studies. Oh, right. You mean in terms of, well, obviously the rest of the, sort of 25%. We've so got 25%-ish that seems to be explained by genetic differences. So we've got 75% that needs to be explained by something else. I think by the looks of the literature as a whole, shared environment doesn't seem to explain much, if anything, about handedness, or much about most sort of variables that we look at, actually. Particularly if we measure sort of in adulthood once. So you tend to have shared environmental effects more in childhood, and then as people get older, those effects tend to decrease a bit when people sort of go out and make their own sort of environments for themselves. Because of course we're not passive observers of the environment; we go and make our own environments. One thing I think that's very interesting with this, actually, something Chris mentioned a while back, is this sort of, we may have 75% of handedness or whatever that is explained by non-shared environment, but non-shared environment doesn't necessarily mean environmental effects per se. It also means measurement error. It also means random noise. So it's quite likely, to me at least, that a lot of variation in handedness probably relates to these sort of fairly random processes that we just don't understand very well yet.
Hello, hi, Regina. Here. I was wondering, do you know of any information about sort of concordant traits with monozygotic twins that are that have a kind of prenatal environment which is either within the same amniotic sac or in different sacs, and whether that might make a difference to, maybe a space if they're in the same sac, and so they like take from different hands, or if that's something that.
It's certainly something that's been looked at. I wouldn't off the top of my head be able to tell you exactly what people have found, because usually these sorts of studies, they tend to be fairly small sample sizes. It can also be quite difficult sometimes, for instance, whether there's a shared placenta and things like this, and people look at whether there's a, whether they're dichorionic or and all of this kind of thing. One thing, of course, is also to consider what would actually be a more similar environment, because you might be, for instance, people might think, well, actually, if you have a separate amniotic sac, this is a different environment or something like that. It might be more different, but equally the placement of the twins within the womb, they might say be monochorionic, and they're sort of growing up right next to each other, amniotic as well. But often sometimes you can find that one MZ twin, just through sort of chance processes, will perhaps have, for instance, a slightly better access to the maternal blood supply. And it might be a very small difference to start with, but it can actually then become very, very important going forwards. And you can end up with this sort of twin, what's it called? Twin transfusion syndrome, I think it is. So in terms of whether or not this makes a difference, in terms of, there are some studies on this. I don't know that anybody's done it on a very large scale, because the thing is, of course, that when we're looking at really small effects here, that I'll be reluctant to take a study with a small sample as sort of telling us too much about it. So the short answer is I don't really know, so apologies.
Okay, is there no okay, very quick one. I won't ask a question, I'll just say some things. I'll bow to Nancy Siegel, but I have to say I do not believe in mirror imaging in twins one bit. Interestingly, Bessie and Jessie put up, they've got opposite hair walls. I don't know if you noticed, they're parting from different sides, but they've got the same handedness. So who knows what's going on there. I think most of your problems with MZ, I don't really mean problems that read apart, is power. I think that's the answer. And with those sort of numbers, there were loads of twin studies that didn't find effects. And it's only with the big meta-analysis that 1–2% differences in discordance becomes significant. So I think there's a whole load of issues going on there. The right-hand speed and the left-hand speed separately, I'm not sure they've got anything to do with handedness, interestingly. I think they're probably just motor ability, and that's probably almost certainly under genetic control, I thought, and that could explain a lot of that. It's the fact that the relative difference is not there.
Oh, definitely. I'm not trying to pass off my significant findings there as being relating to handedness per se. It's more we've got the Purdy pegboard task, and it's just interesting as an aside to see if we can detect those genetic effects. And the fact that we did is sort of, as much as anything, it's a bit of a sense check. I think that we have found that, which you would expect to find, but we haven't found the other stuff, which is maybe more indicative that either there isn't anything there or that the effect size is a lot smaller. I think probably the latter. I think that there surely are some genetic influences on strength of handedness. I think we just haven't had the studies with sufficient power to detect it yet.
Thank you very much.
Thank you.